The Edifice Complex podcast is brought to you by DCM, the Drawing Specialists, Tether, get smart, get tethered, Blue Rhythm Commissioning Software, and Sensor Suite, the future of intelligent buildings.
Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator, here with my colleague, official agitator, friend, and Yoda, most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello, Yoda. I am interested in this conversation today because Lawrence Berkeley Labs, who we're going to be speaking with today, I've been quoting stuff off their website in my presentations for the last 10 years. So I've been hideously and unashamedly spouting their stuff. And it's all good stuff, right? So this is going to be an interesting conversation for me.
Yeah, so today's guest worked his way into a project manager position at Lawrence Berkeley National Laboratory. And when we get into the presentation, we'll ask for a little bit of history about the lab because a lot of our listeners don't know about the lab, and we should probably talk about the history of it. It's got a neat story behind it. You also served as an executive director for the California Commissioning Collaborative, technical manager at Clear Results and the Portland Energy Conservation Incorporated. And he was also director of engineering at EnergySys. Welcome to the show, Mr. Eliot Crowe.
Very happy to be here. Thanks for having me on.
Yeah, you're most welcome. So, Eliot, you earned a Bachelor's of Industrial Design from the University of Plymouth, then went under a Master's Diploma in Design Technology and Project Management through Sheffield-Hellman University. By the way, I love your educational path. That industrial design is a useful education in no matter what field you're in. And so why don't you share with us why you took that route and how you used your education in your career path, because it's pretty interesting.
Well, yeah, thanks, Robert. Yeah, I grew up in England, and the industrial design field was very interesting to me. I studied that at undergrad. I had wild dreams and fantasies of being one of these superstar industrial designers, and turned out I wasn't that good. I was okay, but I kind of aimed for the stars, and what is it? You aim for the moon and end up in the stars, something like that. But I ended up getting more into design engineering and project management, and then over the course of several jobs in the UK, and then eventually move into the States, I kind of transitioned more from the engineering side into the actual project management side. And then, I kind of fell into energy efficiency in 2006 when I saw the job at Portland Energy Conservation, Inc. advertised on Craigslist. I thought, well, that seems like something worthwhile to do. It was
good job, recruiter.
Pretty much. Yeah, I'd finished up a job that was industrial manufacturing and thought, well, I want to do something more worthwhile, and energy efficiency. Oh, that sounds good. So I joined PECI, and I just drank the commissioning Kool-Aid, as it were. They were huge on commissioning way back in its origins, back in the 80s. They had a lot of really well-known people there in the commissioning industry. They ran the National Conference on Building Commissioning. They were kind of seeding the Building Commissioning Association. They were just, in it. And yeah. I managed to get a program manager position there. So I spent 10 years at PECI managing utility retro commissioning programs, some government-funded technical research, the California Commissioning Collaborative, the conference, all these things I was kind of just getting mixed up in. And just absolutely loved it. I don't have the qualifications to go into buildings and really do commissioning, but I learned about the process and the people and all the angles, started to get into the more analytics end of things during that role, and then that was kind of my entry point then to go into the Berkeley Lab, which is very much in the sort of analytics realm. Been there for 4 years now as a program manager. So that's kind of my potted history there.
I like, do you know, so I love the fact that you got your job off Craigslist. It's just awesome. Yeah, because most people, I was recruited in by so-and-so, and no. I went on Craigslist, found my job, and it's been awesome ever since. There's a life lesson there, man, already. Right?
Absolutely. Well,
yeah, and it was a good time too, because in Portland at that time, so many energy efficiency businesses were really exploding, and PECI was one company growing so fast that they didn't really have the expectation they were going to find people who had all the energy efficiency experience. They just wanted people that were smart, technical, good fit, and I didn't have any background in energy efficiency, but I fit, I guess.
Nice.
Yeah. It's interesting. When we look back at a lot of our guests that have made an impact in the world in whatever field they've been in, coming out of school with the aspirations of being the superstar, as you stated, realized very quickly that that's not what I made. But they switched, but it was recognizing early on in their careers that they needed to make a move. Rather than getting stuck and hating their lives and hating their jobs because they get in a rut. And these individuals like yourself just said, yeah, you know what, I thought this was for me, but it's not, and I'm going to make a move. So good on you.
Yeah, I mean, that's one of the things that separates the winners in the end, is the ability to not get trapped by the sunk cost fallacy, right? I've done industrial design, and if I don't become an industrial designer, I've wasted everything. No, you can pivot sideways and use them skills somewhere else, right?
Yeah.
That is a great lesson.
For a long time, I don't think I really recognized how much of those skills I was using. Just the problem solving, I don't end up with a product at the end of things these days, nothing that you can actually hold in your hands, but it's the same process. You think up a problem, think of different ways to solve it, test them out, come to what works,
Yeah. I know I keep using IDEO. You're probably familiar with IDEO. I mean, really world famous industrial design house. I keep using them because they're a great example, but, we need an IDEO in the world of property development and architecture where you bring, multiple personalities and skill sets to the table. Yeah. And those people may never actually ever step into the building, but, and the stories, of course, that come out of IDEO, especially the ones with Steve Jobs and developing the mouse. And, you just bring everybody from every walk of life that wants to play in the sandbox, whether it's the bus driver, the baker, the engineer, the physician, you all come together at a table and you design the product, and what comes out of it is something that's useful for society, right? Mm-hmm. And in many ways, that building behind you, the Flex Lab, I mean, there's a lot of research work coming out of that lab, and are you part of it? Like, do you actually get to play in the lab at all, or?
No, I don't. I'm part of the Building Technology and Urban Systems division within the lab, and the Flex Lab is part of that. But it's not something I've worked on hands-on. But that the lab is super proud of this. I mean, this building, this part of it right here, you can kind of see the edge of it. I mean, the whole building rotates, so that if you want to test out glazing with different aspects and orientations, then you can test it in one position, then spin it around, test it in another. It's super advanced, configurable, and I know the lab as a whole has been having a lot of fun testing it out and looking for partners who want to use it.
Yeah, awesome. I love that.
It is. It's really cool. And I remember it was like probably now 4 or 5 years ago. We were at one of our ASHRAE committee meetings, TC 6.5, which is the Radiant committee, and the design team came to present us the project because they were looking for input on the design. And Eliot, this is an interesting story. Adam and I actually met at a course, and I was talking about Robert Petitjean's book, Total Hydraulic Balancing. We're talking about valve authority. And Adam, you were the only person in the room that even recognized the term. And anyways, your representatives, your colleagues from Lawrence Berkeley were in our room. And as soon as they started talking valve authority, I thought, okay, these guys know what they're doing.
Yeah.
They know what they're doing. And because not very many engineers do. And when they started talking about the features of the building, and it has Radiant in it, and I know you guys have been part of the large project that the Center for the Built Environment has been playing with in terms of radiant research work, because they've used your lab, I think, for some stuff, if I recall. Yeah, so
for our international listeners, and particularly people from the UK, in my mind, Lawrence Berkeley Lab is very similar to BSRIA in the UK, the Building Services Information Research Association. I can't remember the full name, but so just for the benefit of our listeners, could you just give a quick overview of what Lawrence Berkeley does?
Yeah, sure. Well, there is, I forget the exact number, there's over a dozen national labs across the US, and they are predominantly doing federally funded work. So for us, it's at least 75%. We have to have federal funded work. I think we're actually quite a bit higher than that, but essentially there are all these federal labs, and they each have different mixes of specialties. So in the Lawrence Berkeley National Lab in Berkeley, we have, gosh, I don't know if it's 5,000 people working there, but it's in the many thousands. And we have computer science and biotechnology. There was just an announcement today that one of the faculty who works at the lab, and also UC Berkeley, was one of the co-winners of that Nobel Prize that got announced today.
Wow.
So at the lab as a whole, there's all this work happening across many so-called divisions and technology areas. So then there's the energy technology area, which looks at policy and generation and all kinds of things. Then within that, there's the building technology and urban systems division, which is what I'm a part of. So within our group, we look at building analytics is the team I'm a part of. We have simulation groups. We have groups looking at demand response. Grid-enabled efficient buildings is a big deal right now, and load flexibility. We're looking at indoor air quality and building health issues around that. We also are looking at resilience. These are sort of current focus areas. So we have all these scientists doing research, and it kind of, there's kind of a little bit of ebb and flow in the type of research. We talk about technology readiness level, TRL, and at any given time, the government might be more interested in high TRL research, which is the kind of things where it's kind of close to market, but just needs a bit of an extra push. Maybe it needs field demonstrations of technology, so owners are more, interested in taking that on. At the other end of the technology readiness level is more things that are more in the nitty-gritty of nearer to pure science, answering theoretical questions that may answer questions, and become products in 10 years' time, let's say. Right. So that the government, the trends can change over time, whether they're more interested in one end or the other. Within the building technology and urban systems division, we don't tend toward pure research, but we kind of do demonstrations. We do sort of, let's take an example. So for fault detection and diagnostics technologies, we might work on refining algorithms and applying machine learning or AI, let's say, to those algorithms, which may not necessarily drop straight into a product once we finish our project, but it kind of pushes the industry along, on a longer term basis.
That's interesting. It's in property development and construction, R&D is a very underrated, underreported, underfunded thing, right? And you're essentially an R&D for the built environment, right?
Mm-hmm. Yep.
Yeah. So it's outsourced. Right? To some degree.
Yeah, and we make our papers and research free. We love to collaborate with industry wherever we can to make those connections and see that our work is relevant. So we're asking the right questions, and also that when we're done, we can actually get the word out.
Excellent.
I think it was Lawrence Berkeley that there was a technology. It was a radiant cooling panel, so it was discharging during the daytime to atmosphere and cooling fluid. So rather than being an absorber for heating up fluid for conditioning buildings, it was actually taking the heat from the building during the daytime and discharging it to atmosphere. I'm pretty sure it was your guys' lab that did a paper on that, and it was fascinating technology. I don't think it's commercially ready yet, but if you can think about the applications of that, especially if you could reverse it, so during the day, or I guess you couldn't really reverse it, it's a cooling system, but it's got potential. And in a high performance building, which you guys do a lot of research work on high performance buildings, if you can get the loads down and use large surface area heat exchangers, a few degrees of cooling during the daytime from a collector, or no, it's not a collector at that point, it's a discharge, I don't know what you would call it, an emitter, that's all you need,
Yeah. I'm not familiar with that personally. There's so much that happens in the group that I'm like, oh my God, I hope I don't get asked about specific projects that I look foolish for not knowing about. But.
Well, no, you shouldn't, and you shouldn't, because both Adam and I recognize that what comes out of that out of the labs is, it's huge. The library is amazing, the inventory of documents and projects. So, but I'm like Adam. I have been following the lab for a good part of my career, because what comes out of there has been incredibly useful for practitioners. And when we can stand in front, and as a lecturer for ASHRAE, being able to stand in front of a group of engineers and architects and advise them about what the lab is learning and information that they could use in upcoming buildings, and that, of course, that has a huge impact on society. So,
I must say it's a fantastic part of working at the lab too, and I found this to a certain degree at PECI as well, that when you go out and meet people and talk to people, you realize you're kind of benefiting from the reputation that you weren't necessarily part of creating. People really respect the work of the lab and are interested to hear from us and share with us, and it is really, I feel very fortunate that I can do that.
Yeah, standing on the shoulders of others, but that's where progress comes from, because all progress is incremental innovation mostly, right? Radical innovation is unusual, right? But I can tell you, I shamelessly stand next to that logo and repeat some of the things that come out of that lab and claim the glory personally. So I used to start some of my commissioning presentations, if I was speaking at conferences and that, I put up it's an old slide. I haven't used it for a long time now, but it put a slide up, and it was some research back in 2000 by Lawrence Berkeley Labs about all the defects and problems found in buildings. Because it was you guys asking the questions, I think people were very forthcoming. And it was just this 8-bullet list of so much of it is design issues, so much of it is this, 15% of all problems are missing equipment. So let's be clear on that. That is a job that's been designed, installed, people have been paid and gone away, and someone's gone, hang on, where's the compressor?
Balance in valves.
Yeah, it's so nice that those problems don't happen anymore, though, right?
Yeah, absolutely. The last bullet on that thing was, and the cost to the built environment, if you aggregate all the developed space in America, the cost to the built environment was $3 a square foot. Now, in the US, that is a massive, massive number. That was the cost of not commissioning properly and handing your building over working properly. It was estimated back in 2000 at $3 a square foot. Let's say that was out 50%. Let's call it $1.50 a square foot. That is still a gargantuan number.
And you will know this probably better than me, but that the structural reasons for why that happens, they're not completely gone away. Who pays the first cost and what do they pay it based on, and who gets to pay that $3 penalty? Is it the people that are building it, or it's the end user. Those things haven't gone away yet.
My theory on the importance of Lawrence Berkeley Lab, apart from his reputation, is we have to admit that there's a lot of commissioning processes go, and then post-occupancy will do this and this. That's a fantasy. Because the way contracts are built is you build that building, you get paid, and you run as fast as you can in the opposite direction once you've got your money. Right? That's just how it works. And all of that is based on first cost decision making. So the importance of Lawrence Berkeley is if you can come up with a technology that is cost effective and then can be incorporated in that's relatively passive or low maintenance, that is actually a massive impact on the life cycle of that building. Right? My favorite example of that is solar wall. So I worked on a project in Canada which had the largest installation of solar wall, and on a -20 day it was giving a 20°C lift in outside air temperature.
Wow.
Zero maintenance, zero moving parts. Right? what's not to like about that, unless you're the
Yeah.
union dude on the FM team? So
Yeah.
this is why Lawrence Berkeley Labs is important. So I'm saying that because one of the things I want to talk to you about today is the new publication that's come out, Energy in Buildings, which I think was a partnership with yourselves and the Building Commission Association in the US. So I want to talk about that because I think the stats I used to quote in my presentations about the defects in buildings came from an earlier iteration of that study. So do you want to tell us about this new publication?
Yeah, absolutely. I'd love to. So the original publication was 2004, and this was effectively a cost-benefit meta-study for commissioning, which touched on the energy savings, the non-energy benefits, and some of what you described in terms of characterizing the types of defects, etc.
Yeah.
5 years later, that was expanded, and that's probably the most well-known version of the report in 2009, led by Evan Mills, and that was about 600 projects worth of data. I forget if it's 600 projects or 600 buildings, but a fairly sizable database of commissioning projects going over a couple of decades, which has been many, many times cited in terms of the energy benefits, the non-energy benefits. We saw that the time was passing, and it got to 2017, 2018. I forget if the original suggestion came from BCA or from the Berkeley Lab side, but we ended up in conversation about, well, let's see what the numbers look like now, 10 years on. And that was not just thinking about, the base, let's call it basic commissioning, have those metrics gone up or down, but also thinking about some of the more emerging practices. If we went out and got data now, would we see more on the monitoring-based commissioning, the analytics, envelope commissioning? Would we see things expanding out of HVAC and more into lighting and other systems, those kind of things? So we kind of set off to gather more data. So the Building Commissioning Association was collecting data from their own members on projects. We reached out to utilities, notably ComEd and BC Hydro up in Canada, were very strong supporters. We also got support in California from their monitoring-based commissioning partnership program. And so that saw the database increase to almost 1,500 buildings where commissioning had happened, whether it's new construction or existing building. And that gave us a chance to see kind of in two ways we looked at that. One was comparing what we collected in 2018 to what we saw in 2009. The other was, if we combine everything into one single database, what are the high level numbers there? So that the work was done in 2018. It always takes a while to get papers published, so that just came out now. And so, yeah, it was really exciting. The 2009 report, I was on the other side. At PECI, we provided some data for that. We used that in many presentations, just like you. We had all those slides that reported the stats. So it was great to be a part of updating that study. I think that it was interesting that the stories that came out in terms of costs and savings for existing building commissioning, if you just looked at a single number of the median percent savings, it was a lower number than was reported in 2009. It was around about 6.5% whole building savings. And so we kind of dug in to try and find out, what could we find out in the sample composition? Is there anything about the characteristics of the projects that's changed? And I think that the biggest factor we saw was that whereas in 2009, the data that was collected there was a real mix of, let's call it commissioning on the open market versus utility-sponsored projects versus monitoring-based commissioning projects back then. I think back then things were very much dominated by this kind of boutique-style superhero commissioning projects that were gold-plated, high quality, and it was, it was really good quality stuff. And I'm not suggesting what happens now isn't good quality, but I think that as things have scaled, you find the economies of scale, and it doesn't
Yes.
mean necessarily you're able to get 60% every time, but you've got something really cost effective. And the utility programs particularly were just about 25% of the 2009 data set. They were about 80% of the more recent data set. And it just seems to be the case that utility projects don't reap as much savings. They do it very cost effectively. They have a very streamlined process. They also, I know firsthand, have a lot of paperwork and scrutiny on savings calculations and all these things. So I think, in that respect, to be able to get 5 or 6% whole building savings with a 1 to 2 year payback at scale is really good. But you just have to be able to get over the fact that, as a median for the whole study, 6% savings sounds like it's a lot less than 2009.
Yeah, but I mean, a 2 year payback, if it's straight line payback, that's good in anyone's book, right?
Absolutely, yeah, and the costs were really reasonable. They can get in and out, consistent process. I think it's certainly a success story on the utilities there.
I do have a theory about the utility side of things. You were saying, they're very, the returns weren't quite as high, but there's a lot of scrutiny on paperwork. I think with the utility side is, and this is one of my sort of issues with it, commissioning for utilities is I'm changing the lights, I'm doing this. So, the calculations can be robust in terms of the predictive value of the calculation is quite high, right? But when you get into a building, and this is the systems approach to commissioning that I'm a big fan of rather than the equipment approach. So I would characterize that utilities are more equipment-based approach, whereas real commissioning is about systems. So when you get into the systems level, you talk about a VAV system and the building's the system, then predictive value of the calculations is hard because you're dealing with multiple moving parts. I've yet to meet a VAV system that's 2 years old that's actually working properly, ever, in 39 years, right? On paper and in the energy model, they are awesome. In reality, not so much. I got fired as a retro commissioning guy because we came in and our thing was to lower the energy bill, and we found all the outside air dampers were fully shut. So we opened them and got them working properly. Their energy bill went up, and out the door went Adam and his team.
Yeah, that's a tough one. That is a tough one.
Right? Just the slings and arrows of our business. So I think utilities being in the commissioning business is a little bit difficult. It's a red herring. I find it, a bit unpure. If you like, what I mean by that is shouldn't really be in the commissioning business. The commissioning business is about systems. One of the things, the differences between, say, a UK approach and a North American approach is the UK approach is very systems based. There's a lot more hydronic systems. Cost of energy is higher, cost of water is higher. So there's a lot more thought, for want of a better word, and completeness in the design of buildings. And the supply chain and construction chain is set up for that. In North America, Canada and America, it's an equipment-based approach. Pretty much everything is, if we're first cost, let's get that HU, that rooftop unit in, and we're done, right? So, 9 out of 10 buildings are a rooftop unit, bit of gas, boom, walk away. And until you can move away from that and get into radiant systems, hydronic systems, I think, North America's hitting the limit where it can affect a change without a cultural change in engineering. Do you know what I mean?
Yeah.
To a more radiant-based.
Well, we're certainly seeing the effects of our design build culture for lowest first cost now that we have to deal with the pandemic, and the inabilities of HVAC systems to handle some of the health demands or demands for not improving people's health, but improving the health of the environment. And not only in terms of HVAC systems, but it all comes together under the umbrella of indoor environmental quality. So lighting is there, sound, everything else. And I know, both Adam and I are very strong believers of separating ventilation systems from thermal comfort systems. My entire practice, 35 years, we had independent systems. That's the way I was taught. And when I look today back at those projects during this pandemic, I'm grateful because our clients have ventilation systems that are dedicated purely for maintaining the quality of the air, and it doesn't conflict with the thermal comfort system. So they can operate them independently, or they can operate them together depending on the requirements of the load. And there's a big bonus for that. And Europe, as you pointed out, that's a standard system over there.
Yeah. So
Not
I guess
so much here.
This begs the question: are Lawrence Berkeley looking at ventilation rates, given what's going on in the world with the pandemic? Are they doing any research on ventilation rates and effective ventilation rates for health and safety? I guess is what we're talking about here, right?
Yeah, yes, we are. It's not something I'm directly involved in, so I'll be mindful of how much I say about it. But yeah, we have things around both on residential and commercial as well, like indoor air quality and ventilation. We're starting to kind of plug that into some of the COVID-related questions. So I won't say too much, but yeah, definitely it's something that's interesting to us. The extent, it's interesting what you say about the radiant and systems and separating the ventilation and the conditioning piece. We often have to be careful with research in terms of how much effort are we putting into making what's there operate more efficiently, because we all know how much potential there is for doing that, versus trying to push the market forward to adopt more of these technologies that I don't think you'd even call them cutting edge anymore, right? It's like these things are well established, they're just not well adopted.
If it was good enough for the Romans, then it's good enough for me.
And that kind of, to some degree, these kind of issues, we have to stop and think, well, is this a problem that research solves, or is this a structural industry problem that someone else really is better placed to solve that? And so I'm not suggesting I've got a position on that, but that's the sort of our approach that ends up with us often trying to make the existing paradigm more efficient, even though we accept that ripping everything out and replacing it is ultimately the more ideal way to do things.
The Edifice Complex will continue in just a moment. Can you find the drawing and supporting documents you need in less than a minute? Now you can with Echo. It's simple. Just type what you're looking for and press enter. Echo knows your building. Speak with a drawing specialist today. Ask about our special offer of painless onboarding plus 6 months free with Echo. Visit podcast.thedsoffer.com. That's podcast.thedsoffer.com.
Robert, I have questions. Why aren't our buildings more like cars? Shouldn't our buildings warn us if something is wrong and could impact our health and safety? Why can't our buildings tell us how efficiently they're working? Why?
Well, they fit, Adam, and they can. Our philosophy is designed for people. Good buildings follow. This whole indoor environmental quality thing is becoming real important all around the world. Well, Tether have developed a mobile access property identity engine, and that enables landlords and property managers to monitor indoor environmental quality metrics plus energy consumption. It's all about making better decisions based on real-world information. Get smart, get tethered. For more information, go to tether.co.nz, and you can also hear from Tether CEO Brandon Van Blurk on our June 2020 episode of the Edifice Complex podcast.
And now, back to the show.
Yeah, I have a lot of sympathy for you, Rob, because there's a fine line between being an august research association and then being a lobbyist, right? There is a really fine line there.
Yeah.
But I think the real power of someone like Lawrence Berkeley is if you can show through your research that something is just undeniably great, awesome, tremendous, super, then it's on the industry to get to the point where they can't ignore it, right? Because really the industry is driven by money and first cost. So unless there is a change in building code or a directive, then the next best thing is something that is so just undeniably correct and the right thing to do, right? That's the only other way it happens. I think it's driven mostly in Europe and UK by the fact that energy costs are higher and the building regulations are a lot more robust, let's say, robust rather than dog shit like they are in North America, excuse me. But I'm the lunatic, by the way. Robert's a sensible one.
Well, it's interesting you say that because, one thing I've been really fascinated by in my time at the lab here. So it's back in 2006 when I joined PECI, the reason I was hired was they had to grow because they were launching utility retrocommissioning programs. They had 3 big programs they were launching in California. It was kind of the first time that programs of that scale had been attempted, and oh boy, it was hard. And just without getting too much in the weeds, Adam, you kind of alluded to it, that fitting retrocommissioning within the typical utility program paradigm, it's an odd fit. And I think that, I'd like to think we did a fairly good job of dealing with that, and the data from the commissioning study that's just published suggests that other utilities have really extended that and done a good job with it. But it did feel a lot like every day you had to, it was like one hand was throwing money at owners to do something to operate their buildings better, and the other hand was like trying to punch them into submission to actually do it. And you were giving them money and free technical consulting and all these things, and you'd end up feeling like you got good results, and you would just cross your fingers and hope that some of them might stay a year later. It was hard and it was uphill, and I believe that it was good in the end, and it got good results and real savings. But that was kind of my experience of that. And since being at the lab, one of the programs that was launched at a similar time to when I started, I wasn't deeply involved, but had some involvement all along, was the Smart Energy Analytics campaign. Is that something you've heard of?
I'm a big fan of it, and I've heard different variations of it, but I've not heard that actual word combination.
Yeah. So the campaign actually just wrapped up, and we're just about to go big with some media splash of how that all ended up. But through that campaign, we connected with organizations that are using analytics, so fault detection diagnostics tools, energy information systems, some cases of automated system optimization. And it was an opportunity for us to provide some technical assistance to them, for us to learn about their kind of typical practices and some of the best practices that are working for them. We gathered data from them so we could actually document the impacts, energy impacts, non-energy impacts, what they're doing with analytics, all these things. So we're just kind of publishing the final results of all that right now. But something that I have found so encouraging is that from my old paradigm of, being so hard and throwing money at owners to optimize their buildings, to now see what organizations are doing without needing to be bullied into it with the analytics, and just getting to the basics, getting control of their data, then starting to see fairly quick savings in the way you might with a retrocommissioning project, then maintaining them. And some organizations who've perhaps been doing it 5, 6, 7, 10 years are starting to innovate and coming up with new ways that really fit their own unique circumstances, or pushing the technology, and to see all that happening in a way that suggests that they believe in it, it's right, and that they once they've been doing it a few years, they get beyond this idea of what's the payback. Oh, you need to justify the investment every year if you want to keep your subscription up. It's just the way they're doing energy management. And I one quote that really stuck out from one energy manager talking about their tool was that they just said, well, this is just, you asked me to do a job. This is the tool that is going to help me do the job you've asked me to do. And you think about that. You think about how many energy managers, engineering directors have a certain responsibilities and really just don't have the tools to do their job the way that everyone wants it done. So it's I forget your exact point, but I guess it ties into the point you're making about you have to make something seem like it's just the right way to do things, and it's the way. And through this campaign, I think we've managed to document so many leading companies that hopefully people will look at them and say, oh, if they're doing it, it must be a good thing to do, and they're getting results. And I hope people really take that on.
The holy grail, I guess, I think we are at a moment in time where there's some fundamental change going on, and the confluence of high-speed internet through 5G. I think buildings will become 5G nodes. the ability of, like, for instance, Belimo have a range of dampers and valve actuators now that are 5G enabled. You can put that thing in, doesn't need a router, and it can just start uploading to the internet. Data acquisition machines, I call them, right? So the holy grail, though, for any automated control of a building is persistence of performance, right? You're trying to get that curve to be straight. So the performance becomes predictable. The energy model becomes the outcome rather than an aspiration. That is really where it's going, I think. And I was interested to hear you talk about fault diagnostics and auto optimization, because auto optimization and fault diagnostics, I mean, that is when you get to that level, and it prompts the FM team into, right, there's a fault on channel 4, go, because leaving this for 2 days is X dollars per day in energy. That's when you get to that level of algorithm and automation, man, wow, we're in a different world at that point.
Yeah, I agree. And I think that, we're even, looking one step beyond that is the idea of optimizing and reaching this optimized state. It will be dynamic, of course, but I think there's also a recognition that with things like, grid instability, grid events, I think it's not just this ideal of optimized, it's also, can it be responsive? And that's going to really make a difference too, I think. But in terms of the fault detection diagnostics, I think that we really have fantastic tools available right now and ways to use them. There are a few gaps in how to make it all fit together, but it's here for sure.
Are you working at all with any of the International Energy Agency annexes? One that comes to mind right now is the newest one about human occupant behavior in buildings.
I'm not.
It seems like there should be some communication between the groups, because you can look at the building and the building systems and optimize it and achieve these kinds of savings, but at some point there's somebody running that building. There's occupants that are opening windows, turning on lights, turning on computers, running the conveyor systems, and it just seems to me that there's a communication path there that should exist between what your lab is doing and and the people studies that are being done, and these are done on a global basis. There's some huge opportunities there, I think.
It makes perfect sense. I can't be sure that we're not working on those. I mean, I've heard reference to annexes, but whether we're directly involved in that one, I'm not sure. But yeah, it's occupants is where it gets messy. It's hard.
Right. But if we could, you're talking about responsiveness. I mean, there's the mechanical and electrical systems responding to events, but then there is the human factor and how people are operating those buildings, which come into play. And we were talking earlier about Robert Petitjean and total hydronic balance, and his big thing was that you can design the most perfect building, mechanical, electrical systems, architectural systems, but if it's not balanced, then you'll have overflows and underflows, and in both cases, occupants will start to do shit like open windows in the middle of winter because they're overheating, because the heat terminal units are delivering more heat than what was designed, and now you've got large delta T's on that system, and then you have other ones that are underserved, so now you have a narrow delta T. It's a mess, right?
Yeah.
People matter.
Yeah, I mean, we tend to in the work that I've done, we will interface more perhaps with the operations team, who are also human beings who can make an impact for sure. My work is sort of interfaced with them more than occupants, but I'm sure we've got other work going on a bit more occupant focused for sure. And you're absolutely right. I think that you cannot, it's one of those things you have to be careful as a sort of a research institution, is that we can't stick our head in the sand and say, well, here we go, we've given you the perfect research answers, this should work, because human beings really have a big impact there. And I think that it's one of those areas where for me personally, I wonder what's the best way to tackle it, because things like operator training, just take that one example,
Yeah.
operator training or training and certification for energy managers that has a strong analytics bent to it. It's not our sweet spot. As a national research lab, we're not pushed to do training and certification. That's not really our role. But how can we be useful in making those things happen? How can we make sure that need is surfaced, and that if efforts are happening, can we be engaged in them? I think I'm always looking out for ways to engage on that level if we can.
Well, I think there's two buildings that we've used frequently in both in our presentations and here on the podcast, and that's the NRL building in Boulder, and then also the Manitoba Hydro building. So both of those, are owner-designed, owner-operated buildings, and we had a great presentation at our, I guess it was 2 ASHRAE meetings ago. It was an update on the NRL building. So now it's been running several years, and they were talking about systems, all about systems, but also about people. And both buildings, both clients talk about the culture of the culture of the people in the building, and because many of them came from other buildings and occupied the new building, and so they came with them their own biases about how buildings should operate, how they should function, what they should feel like. There's this whole pre-programming that they came, and now they're in a brand new modern building with a lot of automation, and they taught, and the operating engineers were quite forthcoming about the time it takes. 2 to 3 years sometimes in these large buildings to get a building in harmony, if you want to put it into musical notes, musical terms, where everybody is singing the same tune. And I think that's, a lot of people don't realize that it can take 2 to 3 years to get a building properly tuned up.
Yeah.
We've in our both, not so much in Adam, I don't know if you did too much on the custom residential stuff. We did lots of custom residential stuff. Some of the homes that we were involved with took just as long to design build as a 30-story high rise, and the systems were no different. They were advanced, complicated systems, and people that would commission these homes, these are large projects, seem to think that, okay, you move, it's like a car, you get inside, you turn the key ignition, and you drive it. That's not how it works. No. And oftentimes the excess energy that's used was a result of, in the case of the bigger buildings, having to integrate the mechanical electrical systems, but also integrate the culture of the people that are operating and working in the space. And that applies to all buildings, residential, commercial, institutional, industrial, doesn't matter. It's the same story.
Yeah, I totally agree. And again, going back to my sort of initial education, I got to go to many buildings that we did retro commissioning on, and you get to kind of be in the environment of the energy managers and the operators. And once you get out of your office and out of your theoretical head, and you realize what it's like to be those people. And for us, we think of what's optimal, but we perhaps don't have to think about the risks of when things don't quite go right, and who gets it when things don't quite go right. And that's real. That's people's jobs and their livelihoods, and they need confidence in doing their job and managing what they do. And it takes time. You remind me, Robert, of something else, talking about several years to get a building up to speed. For the analytics side of things, if you have several buildings, you have a campus or a portfolio, it might take you 2 or 3 years to feel like you're on top of the data alone, let alone what you're going to do with it. And it's a tough one, and it's one that I don't feel too excited talking about it too much, because I'd hate to discourage anyone from making that initial leap into taking on analytics, because you see all the software and the way the advertisers, we can get you up and running so quickly, and you can be saving tomorrow, and it's not quite that easy. And I believe you can get benefits quickly, but if you really want to be on top of it, it does take a few years, I think. And that maybe there's a range, but I'd hate to think there are people out there that expected instant results, and put systems out to pasture when they didn't.
That's, you bring up a good point, and I think the owners, the building owners that are also occupying the building. So same with NRL, Metro Hydro. If they hang in there long enough, the 2-3 year period after that, huge benefits. There's a lot of pain, no doubt about it, a lot of frustration, a lot of agony, trying to get your head and hands on what you're actually looking at. Like, what is this actually telling us? But boy, oh boy, once you can do that, then you're off to the races for the rest for the life of the building.
Yeah.
And it hasn't been around long enough. But if you could take, maybe Adam, maybe you've got examples of buildings where you've been doing data acquisition for 10, 15, 20 years. The consequences of being able to understand that and how fine-tuned you can get a building with that long-term data. It's amazing, right?
So what's interesting as we move into data-driven decision-making in buildings, the more data, the better, right? You cannot have too much data. And then you need a skill set that isn't common in buildings at the moment. You need a data analytics skill set. So my personal opinion is the commissioning engineer of the future is going to be a Venn diagram of like a commissioning engineer with engineering background, a controls engineer specialist, and a data analytical person, and someone who can then maybe even modify an algorithm. Do you know what I mean? Someone who can interpret that data. At the moment, my data interpretation, I have to have a trend log. So I get the controls guy, set me up a load of trend logs, and because I understand buildings, I can interpret them, and then I ask him to make some adjustments, right, or her. But in the future, that will probably be an automated machine learning driven thing as long as the data pool is big enough, right? Mm-hmm. And I liked your point about that you made earlier about, there's almost an element of mis-selling. So the construction industry, like the divide between like new construction and there's your building and see ya, So you get your building and you've got all these expectations of it. It's like getting your new BMW, right? Oh, it'll be awesome. And then you get it. And sometimes it doesn't quite work out. And there's this disconnect between new construction and then handover. And then the bedding in period. The construction industry at the moment, contractually and financially, is just not set up for anything post-occupancy. Mm-hmm. I know that a lot of commissioning processes fantasize about a post-occupancy role. I've yet to meet a commissioning person that's been involved in construction and post-occupancy. That person needs a medal. That's a Purple Heart there. But that really has to happen, or it will become a data-driven thing where the design data and the startup data will be then handed over to the FM team, and then that data acquisition will start, and then the tuning will automate. And I think Lawrence Berkeley have a research role to play there in helping with that transition to IoT. It's the Andrew Yang thing, right? So if I'm Andrew Yang, I look at this business, am I saying, so for people outside the US, he was my favorite Democratic presidential candidate because he was young and wanted to change things, which is why he's not going to be the president. But he would look at this business and say, well, FM people, your jobs are going to be taken by algorithms eventually. Maybe, right? Maybe controls engineers, commission engineers, and FM people will over time become lower in numbers, but higher in specialty and skill, maybe. I think that's
I try not to go there personally. Yeah. I think if you I'm not saying it's wrong. I'm just saying that if you frame any conversation that way, you immediately put certain people at the defensive, and it's hard to really work with that. I mean, it's just my personal thing. Like I say, it may be true. Maybe it would just be a morphing of roles and so forth. But we've seen in the Smart Energy Analytics campaign, we haven't seen any evidence that analytics has replaced people. It's more about really getting on top and becoming proactive. And for sure, I 100% agree with your point, Adam, around the skills that people need. 10 years ago, I don't think commissioning providers had people who did Python coding. They had Excel whiz, and they could import data that was emailed to them from a BAS, and now you can plug straight into a data management platform, run things through Python, and just again extending your point, if it's really all about the data and everyone then gets the data, it comes down to what questions do you want to answer? Because you can't just say, oh, look, I've got all this data, I'll spend years looking through all these charts I can make. You have to have the right questions to be asking. So I think that's, I agree with you 100%. I'll steer away from layoffs, but
well, I can make that positive for you.
And
go on.
Just another point to think about evolution is, last time I went to the BCA conference was it 2 years ago? I think it was a couple of years ago. And I'd not been there for a few years, and I went in thinking, well, I'm really curious now that I know more and more about the analytics side, and monitoring-based commissioning. What is the commissioning industry? What are these people doing to integrate that? How are they incorporating analytics? How could they? And I guess I had kind of idealized notions of firms just embracing it and using it as a way to improve their commissioning processes, to get more of a long-term engagement on projects. But as I had more conversations, it wasn't clear to me exactly how they do that. Does a firm that specializes in retro commissioning, do they get their own subscription to some kind of analytics and then go partner with them to go offer their services in conjunction to owners? Or do they let owners decide what analytics they want, and then the commissioning provider has to learn 10 different tools to be able to support those owners? Didn't seem to me a really clear, easy business model there. I'm curious what your thoughts are on how commissioning industry as a whole can really embrace it.
I think what has to be resolved in the near future is who owns the data. So I'll give you an example. I buy the Belimo valve actuator, which is a data acquisition machine. Now, who owns that data? Belimo, the owner, the FM people, right? So who owns the data is going to become important, because the data is going to become valuable when it forms a large enough pool. And it could also, one of my theories is that data could be sliced and diced and sold, and it can be sold to design teams to do what I call evidence-based design, really know when the demands, the peaks and troughs are there. So you can control and select systems. But to take the positive side of the possible job apocalypse, I don't think there will be a job apocalypse, because technical innovation like this can be push or pull. At the moment, it's tended to be a tsunami pushed on you. But because the construction industry changes slowly, and even if it accelerated, it would still change slowly, there are enough baby boomers leaving the industry and not enough people coming in. I think there will be a natural attrition. Mm-hmm. And then the people coming in will be more IT, computer literate, for want of a better word, be more comfortable with analytics, as well as having some of the fundamentals. And there will be this natural evolution into the what I call digital commissioning practitioner, right? Who will have that multi-skill set, I think. But there will be this messy period where there will be the overlap of the people my age and the people my kids' age sort of butting heads a little bit, But I really believe we're entering a profound era of change that is going to be forced on by things like environmental issues, climate issues, pandemic issues now, skill issues and availability, educational issues and availability, technology issues, IoT. All these things are sort of, this massive Venn diagram is dumping on the table, and it's going to resolve over about a 10 or 15 year period, I think. And it will be okay to do it over 10 or 15 years, because one of the benefits of slow change is that change can be worked out. That's my personal view, read of it. I have nothing to back that up. But if Lawrence Berkeley want to tell me I'm good, I'm all right.
Yeah, well, it sounds, I agree. I think that the rate of evolution in the last decade, I think, has been amazing in terms of the analytics tools, particularly data storage, data communications, the capabilities of software as well as the user friendliness of that software is just like night and day from a decade ago, I think. And I think that so much is set up to have greater innovation. I totally agree that data is huge issue. Ownership of it, cybersecurity of it, is another huge aspect of that. But yeah, and I mean, I'd be curious if education is adapting to that vision you have for 10, 15 years time. Is data science a big part of mechanical engineering, undergrad these days, or maybe it's more natural to think that data scientists who are studying right now might just fall into building commissioning without really knowing one end of a air handler from another. I don't know.
That's the danger. So you get what I call software jockeys. So on some building sites, I go on, there's normally a dude in a panel with his laptop. He's got his headphones on and he's banging away and he thinks he's doing work. He has no idea. So he's writing code, he's uploading software routines. He has no idea what's on the end of that software routine, right? And that is the problem today. There's this gap between a software jockey and an engineer or a technician. And that gap has to be closed. Mm-hmm. So to your point on education, I just saw my daughter go through a 4-year engineering course at NYU, and I got to tell you, that course sucked. If I had my time again, I would have sent her to the UK. I'm not saying that because I'm a Brit, I'm also a Canadian, but it's because half the people who were taught her couldn't speak English very well, and it was all about how clever they were in their book. You got to buy my book and it's $300. And they came out with pretty good math skills and some fundamentals, but really no useful marketable skills. That course should have been half fundamentals, half practitioner-led, where someone comes in and gives them a data science semester, someone comes in and gives them an engineering management semester, just some round skills, so when they're in front of an employer, they're a bit more rounded, right? They're not just someone who knows how to run out a calculus formula.
Yeah.
I mean,
oh, well, that's not too encouraging.
Elliot, that's a great question. And from an industry perspective, as soon as you asked that question, I immediately thought of that quote, and I think it was attributed to Henry Ford. And they said, Henry said, had I asked my customers what they wanted, they would have said faster horses. And industry, if you get down in the weeds and you ask a lot of the directors of education curriculums within the industry associations, they're just regurgitating old material. It's just there's no ability to do as Adam is doing and as what you've sort of observed, looking at what's needed in the future. Let's just take what we have now and make it a little bit better. And so there's incredibly small incremental changes that are done. Mainly it's done based on changes that manufacturers have done to their particular widgets. So they're upgrading, maybe the control companies have upgraded some controls. And so, they'll do a program on that. But as far as industry down in the trenches, not happening.
Yeah.
And we were talking, there's another stat. It's something like over 60% of all the buildings on the continent are under 20,000 square feet. And most of those are not designed by anybody, like in terms of the mechanical electrical systems, particularly mechanical systems, are not designed by professionals. They're not people with engineering degrees. They're people who have come up through the trades or worked in the wholesalers. They were taught by the manufacturers or their previous employer, but none of them have the scientific background to even consider what we're talking about here. That's most of the buildings in North America.
Yeah, and I'll be honest, I don't know that we, in my own personal work, have done a great deal to serve that market. I think it's often been recognized as an underserved market, the small commercial, many buildings. I think that proportionally, it's many more buildings, but the larger buildings each embody a larger energy footprint. So I think bang for the buck, hitting the large ones there's a lot of sense in that, but there's a lot on the table, and something that certainly is coming into clearer view across society. I think is just questions of equity.
Yes.
Energy equity and environmental equity, and I couldn't really barely do it lip service, but I think that we're at least starting to recognize that a little bit more of like, well, okay, well, what might it look like if you think about energy analytics in a more equitable way? You know, how could we reach more people, a broader swath of society? Like I say, I cannot make any claims to results, but I think there's certainly a question that's coming up more and more in the energy efficiency industry as a whole.
I think there's a potential role for someone like Lawrence Berkeley, who've got this reputation, right, to be an education provider, to plug that gap. I mean, the fundamentals are important, and that's what universities are teaching, but they're not teaching the practical practitioner side. Yeah, and there's maybe a role, you need credibility to do that, and someone like Lawrence Berkeley could collect people like Robert, Peter Rumsey, people like that, who could deliver that level of training. This is really how you design and select a pumping hydronic system. That never happens in university, ever. Them words will never leave a university lecturer's mouth, right? So the person to find out how to unravel the big secret of how to design a hydronic system, select a pump, has to be lucky enough to be mentored by someone like Robert or Peter Rumsey, who will then, when they got the time and they're not stressed out, impart that knowledge to them.
Yeah.
And Adam's in that camp too. We'll recruit Adam for sure.
So, I don't know, maybe there's that's what you're going to leave this podcast with, a new business model for Lawrence Berkeley. Run with that, become vice president. Go.
Thanks.
So where I'm at.
Well, I mean, I do know that within the lab as a whole, there's a lot of outreach to the local community, for sure, educational establishments. I think that's maybe more generally in terms of science and so forth. But yeah, it's a great suggestion. We're like I say, we're asking the question and looking for ways to be more engaged with newer audiences too.
And it could be a revenue generator as well, right? Because your reputation is sterling. Anything you do would have credibility, and God, there's got to be a revenue stream somewhere.
Adam, I am shocked. I am shocked. Usually, before those kinds of words come out of your mouth, you've got a contract to sign.
Yeah.
I'm so disappointed in you today.
So anyway, I'm conscious of how I've really enjoyed this chat, and we've been rambling on a while now. I'm conscious of your time, so we're going to wrap up soon. But we normally finish with some sort of rapid fire questions. So we just, because one of the reasons we started the podcast, we want to expose graduates and undergraduates and people young in their career to people who are making a difference, who are doing good work, right? And some virtual mentoring, if you like. So my rapid fire question to you is, what advice would you give to someone who was not like you, who were not sort of like started off, I want to play for Chelsea and I can't play for Chelsea. What do I do now?
Don't talk about Chelsea. You picked the wrong team there. I'm sorry, Adam.
I'm from West London. What can I say?
Don't be talking about Chelsea. Sorry. You can say Tottenham Hotspur, but
we call Nam, Tottenham.
Sorry. Say the question again there, Adam.
So
sorry,
how would you advise someone to do a sort of horizontal career switch? What's the steps that they need to take? How do they do that?
I find that people in this industry are really happy to share what they know, and so I would, I use LinkedIn fairly regularly to connect with people. I'm always happy to accept invitations to connect with people on LinkedIn. Most people I know are, and just talk to people, reach out to people, try and schedule 15 to 30 minutes to have them share about what they do, and see if at the end of that conversation you can get the names of 2 other people to connect with. And very soon you'll build up a picture of lots of different people doing different things, and that doesn't necessarily get you a job, but I think you just need to start connecting and speaking the language a little bit. That would be my number one suggestion.
That's right. Don't be in a vacuum, right? Reach out. There's always someone who will speak to you about it.
Very
Yeah.
much. So.
Advice.
Yeah.
So I have a question for you, and it has to do with if you were asked to speak to a group of high school career advisors, these people that go back to their high schools and they're trying to provide career advice to 16, 17, 18-year-olds. What would your advice be to them? What would you say to these advisors?
Well, I would want to leave them feeling that there's a really exciting career in operating buildings and just being part of a team, providing a comfortable environment for potentially hundreds of people to problem solve every day, provide good service every day. The fun you can have with software and analytics. I just think I'd love to really imbue them with that as sort of just to excite people, to get them to a point of saying, I never even thought about that. Because you never see them, right? It's like, you never see where building operations really happen when you visit those buildings. And just to have people understand, that is actually a thing. It's a career, and it's actually kind of exciting, even though normally you end up in a room without windows underground.
Keep that quiet.
But somewhere,
Yeah, you're right. That is absolutely a great observation. There are so many what I call hidden careers, right? Because everyone goes, I'm an engineer, I'm an architect, right? But there are so many variations on that, and so many sub-specialisms that you can go into. I mean, there's got to be something for everybody, right?
Yeah, totally. Yep.
Yeah. Okay. Awesome. Well, thank you, man. Thank you very much for your time. Really enjoyed speaking to you. Is there anywhere where our audience can connect with you, and any Twitter handles or any?
I don't twit, but find me on LinkedIn. I'm easy to find there. And if you go to the Berkeley Lab website for the Building Technology and Urban Systems division, you'll find details on me and the team I work with, and all the great research that we're doing. And it's all that work is published for free. You can find a lot there. And if you we're not experts at website design, I'll say that. We do a pretty good job, but if you're looking for something and you can't quite find it, just reach out to someone. We love to connect with people away from our ivory towers.
The Edifice Complex will continue in just a moment.
Adam, it's time to thank some people who are on our side. Blue Rhythm Commissioning Software.
Blue Rhythm is the commissioning software I've been looking for. Most projects I consult on suffer from poor information and document management. Frankly, it's just chaos out there. Blue Rhythm removes this chaos. It is a secure, always available cloud solution designed to work on any computer, tablet, or smartphone. Their Android and iOS apps allow seamless transition between online and offline work. But what I like most about Blue Rhythm is their painless and fast onboarding process. Our team will bring all your existing forms and checklists into Blue Rhythm for you, or you can use or adapt their pre-built, pre-functional and functional performance test sheet templates. But it's more than that. It enables collaboration, automation, and easy planning and project management for all your projects. Blue Rhythm provides amazing support from a team that really understands your industry. To find out more, go to bluerhythm.com or call country code +1 612 460 8305. Also, you can hear from Blue Rhythm President Andy Martin on episode 26 of the Edifice Complex podcast. Robert, are we there yet? I'm bored.
Adam, I know it's hard to believe, but the future has finally arrived in Canada.
How's that then?
Well, smart remote building and equipment management is now available from Sensor Suite.
Go on.
Sensor Suite, yep, they're an innovator in smart building technology. We like them. They can monitor, control, and optimize anything in your building, saving you time and energy.
You mean Sensor Suite are moving Canadian buildings into the 21st century?
Yeah, I know, another hard thing to believe, but they're doing it, and they're saving owners money with efficiency gains.
Okay, I'm in. How do I find out more?
Got to go to sensorsuite.com or call 1-855-773-6767. And also check out the July 2020 episode of the Edifice Complex podcast and listen to Sensor Suite CEO Glenn Spry.
And now, back to the show.
Adam, another... I said this 100 times. Well, not 100 because I don't know if we've done 100 yet, but we get great guests. We
Yeah.
do. We really do, and we're really fortunate. We're always looking for, as our site says, always looking for thought leaders. And I like Eliot again. Like I like a lot of the stories. Guy has a vision for what he wants to do when he grows up, and realize when he graduates that his degree really it wasn't who he was, and he sidestepped, and now look where he's at.
Yeah.
Yeah.
I liked him. He was very thoughtful. And that story about the shift, the sunk cost fallacy is a really powerful thing. If you've sunk 4 years into a degree, it's hard to move sideways or away from that, right? But if it's not right, you got to do it. I love that story of a successful horizontal move and still using the skills and the knowledge you've acquired. That is perfect success story. Because
it is.
You do crash around as a young person early in your career trying to find your niche, right? And I just got dumb lucky that I wound up in a niche that worked for me. But I've seen other friends crash around until you find that place, and then you're off to the races. So I love that story. It's just quite inspiring for me.
There's I think if you searched Dakota Wisdom dead horse, it would come up. But it's something about, when you have a dead horse or a dead career, you can hire a committee to evaluate the dead horse. You can hire an engineering team to redesign the horse's hooves. You can bring in a veterinarian to try to revive the dead horse. You can put out a government-funded research study on how to revive dead horses and make them useful again. The reality is it's a dead horse. Like, get off of it, right?
Yeah.
And a lot of our guests, not to say that the horse was dead or that their career was dead, it just wasn't riding the way that it didn't feel like the ride that they were looking for, and so they said, time for a change, and they did. So that's a good thing.
Yeah, that was great.
His ability to, because of his career path, be able to sit back, and he has a good macro view of all that's happening in property development and architecture, and of course the associated energy, but also, and of course the commissioning part of it. That comes from being in certain places along your career and to being able to develop, create those pieces. We talked about this before, pieces of the puzzle and how they fit into the picture. And he's developed a really nice picture for himself, and I hope he continues to do that. The commissioning staff that we talked about towards the end, but I want to bring it up now. And you've said this before over and over again, and people need to listen to you and the others that share the same views. And I listen to you, I think, but that is that the data is important. Who owns the data? What you do with the data? Being able to slice the data up into pieces, sell it, use some of it as a design incentives, design tools. Powerful stuff.
Yeah, we really are in a period of change. Lawrence Berkeley are doing great work. I really hope they make a push into research on sort of IoT, monitoring-based commissioning, just the general automation of buildings and the tuning of buildings, because they have the researchability and the gravitas to really move the needle on that and make it so obvious that adoption becomes a no-brainer. Because that's their power, right? Their power is saying, we've looked at it, this makes perfect sense, this is why it makes perfect sense. And then the unsaid question is, why aren't you doing it?
Right. And if you think about like what you just said, and I'm going to sort of tie it back to some of our previous guests that we've had on, that have talked about buildings as sources of energy plants, energy conversion plants, but also then distributing that energy, managing the flow of that energy, which includes data, taking that data and then putting it back into the system. So it's a recycled process. Feedback loop in many ways, right? It's a feedback loop. And so when we bring in guys like Eliot and we consider what he has to say along with the Paul Gezzis of the world and other guests that we've had on that have talked about buildings, sources of data. You mentioned, Belimo, that's a data acquisition device. All these devices are building control systems, are boiler controls, chiller controls, all of them acquiring data. What do we do with it? How can we use it? And and then there's also then let's look at the characters of buildings and the data we get from those buildings. And eventually, and again, you alluded to it, and so did Eliot, and that is that as the database grows along its continuum and it gets deeper and deeper, we can look at it as a character of the characterization of that building. And we could say, well, if you're going to design a hospital and this is the architecture that you use and these are the interior systems and the mechanics you're considering, well, based on the database, here are the characterizations and the characters of that building, and here's what you can expect.
I mean, data it really is the £8,000 gorilla in the room. Just to wrap up on a conversation I had yesterday. So I was speaking to someone yesterday in the Middle East, and we are talking about where's the market going, because there's enough residential buildings and hotels and airports in the Middle East. But when you look at it even worldwide, data warehousing, I don't see any pullback in the growth of that as a sector for the next 10 years. I mean, just the sheer amounts, let's just say buildings do become 5G data nodes, right? That data has to be warehoused somewhere. How many data centers and data warehouse buildings are going to be built in the next 10 years? It's going to be the hot sector, I think, for 10 years. If I was starting an engineering design firm or a commissioning firm now, that would exactly where my focus would be. I would become the specialist, the best at doing that. That is where the market is. Yeah?
Not grow-ups? You'd go into data, not grow-ups?
The other one, I think, won't be as big, but is not going away. Vertical farming term. Vertical farming, right? Yeah, urban farming, vertical farming. That is another growth area, but I think that will wind up being a existing building adaptation project. So a lot of the condos and office spaces that might become obsolete, they could quite cheaply, relatively cheaply, be converted into vertical farms, right?
Yeah,
you keep the structure. Right?
Yeah,
it's a strip out and an industrial refit, so it's not expensive.
Well, we had Dan Knoll on, and of course his episodes will be coming up soon too. But if you had Dan Knoll in the conversation, he would be saying, okay, well, the data centers are a source of heat energy.
Yeah.
And that heat energy can be converted to, heating up water for agricultural purposes or for space heating, whatever. So maybe these vertical farming systems also integrated are multi-purpose buildings, right? Where you've got.
Well, think of this, right? If you've got downtown towers obsolete and it's next to several other downtown towers that are used, you could do an energy transfer. Take the heat from them buildings, heat reject them buildings, use it to preheat what we're calling it, a greenhouse tower. I don't know what we're going to call it, but perfect, right?
Yeah. Well, we had, where was that? Well, we were at one of the interior design firms. We were at a course, and they were talking about converting shopping malls into senior care facilities.
Yeah,
which is perfect, right? You've got the walk around. People like to get out and walk, and each of the stores can be broken up into single or multiple units, right? Yeah. Well, you take one of the great big signature spaces that were at once occupied by a big brand name, right? And that becomes a data center.
Yeah.
The cooling requirement or the heat rejection from that data center could easily be provided for conditioning the senior care facilities. There's some synergies there that are available. Hey, Eliot said something really cool, and I'm gonna steal this. I'll try to remember to credit you, Eliot, if you listen to this after the show. Get out of your theoretical head.
Yes.
I love that.
Yes.
Right?
Yes. Damn right. Should say that to every university professor ever.
Absolutely. You and I have spent a lot of time in buildings and mechanical rooms and having to look at and concern ourselves with the architecture, interior systems, mechanical, electrical. Theory is good. Academia is good.
Yeah.
But if you want to develop confidence in your theories, then you need to have it tested, and you need to get out there and feel, no pun intended, the heat that is put on you by the building managers, the building owners, the occupants, because they will put you under the gun and under the lights, the bright lights, and go, what the F is going on here, buddy? You know?
And one of my mentors used to say to me, Adam, you have to own and confront your horrible decisions.
I love it.
It's the only way you don't make that same mistake again.
Yeah, you have to own and confront your terrible decisions. Absolutely.
Because if you don't, then you're just copy and pasting that decision into the next job. But that was a fucking great bit of advice. Then he introduced me to the 200-pound pipe fitter who told me I was useless.
I know a couple of young men that I mentor too that I'm going to give that advice to.
Yeah. Because there's no the real crime is not recognizing it as a bad decision and repeating it. That is the only crime in life. You get a mistake, right? But if you can recognize it and say, you know what, okay, I'm not doing that again, that is the best possible outcome of that, right?
Yeah.
But then repeating it, no, it's no good. No, it is no good to anybody.
Yeah. I think we've had this discussion before, but I remember over my career that there's been, I don't know, 6 or 7 maybe defining moments where I was pulled aside by an old smart guy. I was a young dumb guy, arrogant though, and thought I knew everything, and I was quickly had a tune-up.
Yeah.
Most of them I was pulled aside, you know. It wasn't done, the raking over the coals was not done in a public forum. It was, Bean, get your ass in here. We need to have a chit chat about your attitude. You know, they were uncomfortable moments.
Yeah.
But I'll never forget any one of them. They're probably the most valuable things that ever happened to me.
Yeah.
Having that, you know, check.
Yeah.
And humility, absolute humility. And kudos to the individuals that have played that role. You know, I never, ever held them in disregard. I always held them with high respect. The fact that they cared enough to pull me aside and say, quit being an idiot.
I'm saving you from yourself. You just don't know it.
Exactly. You can pay me back later. Oh, dear.
Okay, man. That was a good one. I enjoyed that. All right.
Yeah.
So, see you in the next one.
Okay, Adam. Always good, man.
Thank you.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.